Hi everybody, and welcome to this new series of tutorials about creating a video game in Max. So I always wanted to create a video game in Max and finally I have some time, so I've decided to start this tutorial series. So this series of tutorial will be mostly about jitter, but also about general programming in Max, because both are involved in the creation of a game. And so I think this could be interesting for you to see how I choose to solve certain problems and which kind of jitter tricks or methods I use and so on. So the first series will be about the Space Invaders game that I've just created. And so, yeah, let's take a look at the game itself. So let me go full screen. So the game is basically this. There are some aliens. There is a tank, which is our starship or something. And then the aliens are dropping bombs, and I can fire to them by pressing the mouse, the left mouse button. And I have some lives that when they arrive to 0, of course, it's game over. So, for example, if I lose all my life, then the game over appears, and then the game is restart. So I can move the tank using the A and the keys on my keyboard. So it's pretty straightforward. I actually can also move it up, but this shouldn't really be like that. Okay, so this is the first episode of this series, so I would like to start from scratch actually with the creation of this game. We will also look at some other games in the future. I will create some other games that will be always more and more complicated. So for the moment, we will start with Space Invaders. So let's actually create a new patch. I've already created it here. The old patch I will just keep here so we can look at it when I don't remember something. And since this is a game developed using jitter and also OpenGL, so the first object that we need is our jit.world. So let's call this this OpenGL context, let's call it game tut. Then let's give it some attribute to our oh, sorry, this is not a jit word, this is a grid shape. So let's call this game tut. Let's give some attributes to this jit world, and for example, let's have a black background by using erase color, and let's have the full scale anti-aliasing, and let's also have window position. So our default window position, let's actually put it on the left, and then the sides of our window, let's make it a bit smaller than default. And then we also choose the FPS, let's set them to 60. And then we also need to give it the attribute ortho2, because we actually are working on a two-dimensional game and we don't care about camera perspective. We basically don't care about the z-axis of our world. We just want a two-dimensional game. We also don't care about the lens angle, so we just give it the flag 2 to this ortho attribute. So we will have just a two-dimensional world. Then let's attach a toggle to it so we can start and stop our world. Good. Then the first thing I want to create is our tank. So our tank that fights against the aliens. So let's create a subpatch, call it tank. So if we go inside the subpatch, we want to create, first of all, a jit.gl grid shape, because our tank is basically a jit.gl grid shape in a rectangle shape. So let's create it, jit.gl grid shape, game tut. So let's give it some scale attribute. So let's actually make it quite small. Let's scale it something like that, so it will be larger than taller. And then let's give it a color like something like a blue, like a water blue. And then let's give it also a dimension attribute of 4x4, because this is what we need to create a rectangle basically. And then let's also give it the shape plane, since we just want this this to be two-dimensional. We just need a plane. So let's see how it looks like. Yeah, that's our rectangle. That's the first step to create our tank. Maybe we can make it a bit smaller. Something like that. Oh, zero. Too much zeros. Okay, so perfect. And then we want to be able to move this tank around using our A and D keys on our keyboard. So in order to do that, let's create the jit.gl drive, a jit.anim.drive object. And let's give it the command UI listen, so it will listen to the input from our keyboard. Then let's attach it to the object. And we will see that now we can move our tank around. Whoa, but it's quite too fast. Let's create also the anim reset message and attach it both to the anim object and to the grid shape object, so we can reset the position of our object. And as you can see now, it went back to full scale mode, because basically the scale is tied to this jit.anim. So instead of giving the scale actually to the grid shape, let's create a jit.anim.node, and let's attach this anim node actually to the grid shape, and let's give the scale attribute to the node. So we will have that now is the jit.anim node that takes care of the position and the scale and all the transformations of our jit.gl grid shape object. So let's actually, instead of using anim reset, let's create a message position 000 in order to reset the position of our tank. Now, as we see, the speed is too fast for our tank, so let's modify the speed attribute of the jit.anim.drive. Let's give it, for example, 0.1. No, this is too slow. Let's give it 0.5. Let's see. No, it's still too slow. Then let's go with 0.7. And it's still too slow. We can also adjust the speed by setting the ease in and ease out attributes. So we don't want actually any ease in. So we don't want that the object accelerates when we press a key. We just want that it stays at the same speed all the time. So when we press a key, it just goes directly to the speed. So let's set the ease in and ease out to a super small value of 0.1. Let's actually make the speed a bit greater. Let's actually set it to 1. It's actually still a bit too slow. Let's set it to 1.5. Okay, that's quite okay. Let's actually also set in the jit.world object the full screen menu bar to 0, because we don't want any menu bar when we go in full screen. So, perfect. So we actually don't want the default position of our tank to be in the center of our window. We want it to be actually on the bottom. So let's set a default position for this anim node, 0 for the x and 1 for the y and 0 for the zeta. Oh, sorry, it's -1, because the negative axis is the one that goes down. But actually we have also to consider the vertical scale of our tank. So actually we don't want it to be -1, otherwise we lose half of the 8 of the tank. We want to have it something like 0.95, or yeah, 0.95 looks pretty okay. So if we want to reset the position, we will do something like that. Okay, so far so good. This doesn't look like a tank yet, so let's actually create the other components of the tank. Let's create another grid shape, and let's create another jit node. Let's attach this jit node to the other jit node. So this is now will be a child of this jit node, and they will be all child of the jit.anim.drive at the top. So now the transform of this grid shape will be relative to the transform of the previous jit grid shape, so of the previous anim node connected to the previous grid shape. So let's also change the position of this one actually to 0, because this position is now relative to the position of the previous jit.anim node. So let's set the scale to 1 and set the position to actually a higher value for this other grid shape. So this will be the upper part of like the cannon of our tank. So let's actually scale a bit the X sides. Now looks pretty good. Let's actually scale it a bit also on the Y, because we want this to be more like a base for the cannon. So something like 0.4, and let's make it a bit lower also. Okay, perfect. So now when we move our tank with giving an input to the jit.anim drive, then we are actually moving. So we are actually moving the whole tank. And let's take a look actually at the jit.anim drive. If we double click inside it, we can see that there is like kind of a JSON file, and which has inside all the keys mapped to the various movements. So we actually are just using the A and D keyword to move left and right. So with A and D, we move left and right. Okay. So as we can see now, the whole tank is moving together because these anim nodes are connecting together. So they actually put it in relations together, and so they will move together as one. Let's create actually the actual cannon. So let's create another one of these guys. Let's connect this anim node to this guy. So now this will be a child of that. And let's actually scale it. Let's actually move it a bit higher. No, actually the position was okay. Let's actually scale it a bit less on the Y axis and a bit more on the Y. Let's scale it a bit less on the X axis and a bit more on the Y. So we now have kind of our tank. Let's move this a bit. And let's actually scale it a bit bigger. Yeah, something like that. Let's move it a bit up. Yeah, something like that looks quite good. So this is our tank. It's actually a bit too chubby on the bottom. So let's actually reduce a bit this scale here. Yeah, that looks okay. So let's actually add 2 points to the X and the Y to make it a bit bigger overall. That's still too chubby. Okay, yeah. Now it's quite okay. Our tank is ready, so it moves around and it's working. Perfect. So one thing that we want to do now is to prevent the tank from going over the limits of our window. So in order to do that, I used this solution. So every time we move our tank, the jit.anim drive sends out a message with the current anim move message. So what I did is to make it in a way that every time we move our tank, we also send the message get position to our tank. So every time we move our tank, we also send out the message get position. And we cannot just do something like that, send out first the list and then the get position message to our grid shape, because in this case, now I am clicking A and D, but now the jit.anim drive doesn't work anymore because it's not anymore directly connected to a jit.anim node or a jit.gl grid shape object. So what we want to do is to connect it directly to the anim node and then set physically, graphically this message on the left of this object, so we know that the order in which these messages are delivered. Now it's first the move message gets passed to the anim node, and then the get position message gets triggered. So if we connect also this get position message to the anim node, and then we attach a message box to the dump out of the anim node, we can see that every time we move our tank, we will also get the position out of the right outlet of our anim node object. So, whoa, now it's just gone. Okay. So how can we use that? We can use that in this way. So we do something like this. So we use a root object to route the position message from here. And then we are actually just interested in the first number, which is the X position. So we can just extract this number using a $1 property of the message box, so we can just extract the X position of our tank. So this is the father anim node. So this is our main body of the tank, here the base. So this we know that this we don't want to go over the boundaries, the vertical boundaries of our patch, our window. So if we extract the X position, we can actually use this number to limit the position of our tank on the x-axis. So in order to do that, we can do something like this. We can say every time this is less of 1, let's say, and then let's just send a message position. Sorry, this is less than -1 because the x-axis is actually negative on this direction. So we can just say, okay, then stay to the position -1, 0.95, and 0. So we can say like select 1, and every time this condition is met, we send this message to the jit.anim node. So let's see, if I try to go less than 1, now this message will be fired and the position will be set to 1. So this is what we can do. Let's do it also for the other side of the window, so for the right side. So let's do something like that. Let's copy that. Let's create a trigger, float, because we want to send out these two floats in this order. So first on that, so when it's greater than 1, then send this message position 1 -0.95 for the y and 0 for the zeta. And we can say something, yeah, this should be enough. So let's see, if I try to go there, doesn't go. If I try to go on the left, also doesn't go. Okay, perfect. There's still a problem that actually the jit.anim.drive allows us also to go vertical, to move us vertically. So if we go on the vertical axis, we can still pass the boundaries. So if we press the zeta key on our keyboard, we can basically go below our desired y position. So a way to prevent that, we can actually just modify the editor, the key map here of the jit.anim.drive. But I found that this is a bit buggy, because the jit.anim.drive sometimes when you will open it will not load the new file, will load the past, and then when you modify the file, it will load the new file. So it's somehow buggy. So we can basically just do the same thing for the y axis. So let's pack these guys here into a sub-patch. Call this x limit. And let's actually use an unpack object. So for the x position, and let's copy this sub-patch, call this epsilon limit. And let's go inside, and inside here we can basically just have to change those values. So now we don't want that the position is fixed. We want that whenever we press zeta, so we try to go down, we actually don't want to go back at position 1. We actually want to go back at the position where the tank currently is. So in order to do that, we also have to pass inside this subpatch the X position. So let's do something like that. Let's pass the X position also inside here. And we can use the X position exactly here. So whenever epsilon is less than minus 0.1 or epsilon is greater than 1, the position will be set to the current position, to the current X position of our tank. And let's actually set it 0.95 for the up border of our window. So whenever we pass these borders, the position of the tank will be set to the current position of our tank on the x-axis and an epsilon position of minus 0.95, 0.95 depending if we are going below or above our limit. So let's connect this here. Let's test if it works. Yeah, it kind of works. Now I cannot even go up anymore. Let me see what I've done. Yeah, sorry, because I'm using actually a pack object, but this is incorrect. I actually want to use I'm using a POC object, but I actually want to use a pack object. So also here is not actually POC, but is actually the pack object, because we want this message to be triggered only in the case we go above or below our epsilon threshold. Now, as you can see, this is a bit glitchy because our tank goes a bit below our values. So let's see what we can do to prevent that. Yeah, sure, because we said if it's less than minus 1, but actually we have to say if it's less than minus 0.95. Or in the upper bound case, we have to say if it's greater than 0.95. So now it will just not go below this threshold. Sorry, the wash machine was going crazy. So one other thing to note here is that when we resize our window, something like that, our -1 and 1 boundaries are now much farther from the actual edge of the window, because the world coordinates stay fixed, but the window coordinates actually change. So the window size basically actually change. So in order to fix that, we need to know the ratio of our windows, so the x dimension divided by the epsilon dimension. And in order to do that, we can send the get size message to our jit.world. Then we can route from the jit.world the message size. So let's see what we get. Yeah, we get the sizes of our window. So then to calculate the ratio of that, we can just create a divided operator that will automatically divide the first number for the second, so of the list that it receives. So this will be our ratio. So let's send this ratio with a sender, and let's actually also create a metro object that will be with a 2000 interval that will be always active. So every time we change the sizes of our window, we just have to wait 2 seconds before we get the correct ratio again. So then we can use this ratio here in the tank subpatch, in the xlimit subpatch. We can use this ratio. So here we can use this value to change the value of our x limit. So let's actually multiply this ratio for -1, because this will be the actual, since we are using the ortho attribute, we are actually in a two-dimensional world. So the window coordinates map directly to the world coordinates. So basically, if we do something like this, we now can go as far as the actual ratio of our window. So let's try. We're actually getting some strange number out of here. So let's see what's going on. Oh yeah, sorry, because I still have my other patch open, so I'm still receiving the ratio from the other patch. So let's actually call all the senders from our tutorial with a tut. Let's append the tut word to every sender and receiver of this tutorial. So we will now receive the correct value for our ratio. I just realized I didn't put the floating attribute, so our window actually disappears behind the patch. This is not what we like to have. So yeah, now if you see, every time I resize the window, I cannot go below the actual x size of the window and not a fixed value. But as you can see, the tank is now allowed to go half for all its length to above our limit. So in order to reduce that, let's set actually the limit a bit less than our ratio. So let's actually set it, let's actually subtract like 0.1 to our ratio value. Let's see if that's enough. Yeah, that's quite okay. Let's also, let's do something like that. Yeah, that's quite okay. So we can still go up, but our tank is confined inside the boundaries of our window. Okay, I think I want to keep these tutorials short and snappy. So I think for the first one, that's it. And I hope you found this useful. And I encourage you to visit my website and take a look at all the tutorials that I've already made on JIT and visuals inside Max. If you decide to join my supporters on Patreon with a small monthly donation, you can download this patch and the complete Space Invaders game from my Patreon page. So, okay, I think this is it. Hope to see you in the next tutorial, where we will talk about implementing the actual aliens, and we will see some interesting trick to create the textures that represent the aliens. Okay, so thank you for watching and see you on the next tutorial. Ciao!